Hello and welcome to another one in D's ADD videos. Today we're going to be discussing the concept of improper integral. So what makes an improper integral? Well, there are three basic scenarios you need to look out for. Sometimes you will have an infinity or a negative infinity as one or both of the bounds. So here we have an example of the top bound being infinite, or a negative bound being infinite, or you might have two bounds being infinite. In this scenario, you will need to separate this into two integrals and add them together. Sometimes you might have something that is not infinity, but makes your function in your integral undefined. So here you should be able to see that if I plug in that 5 right there, I get 1 over 0, which is undefined. Or if I plug in e, natural log of e is 1, 1 minus 1 is 0. So any bound that makes your integral undefined also makes it an improper integral. Now, it doesn't have to be just the top bound, it could be the bottom bound as well. The final type of improper integral is an implied discontinuity. Basically, something in between the bounds of your integral make your function undefined. So that would be something like this. You should see that 1 plugged into here makes this undefined, and 1 is in between these two. Pi halves, tangent is sine over cosine. Cosine of pi halves is 0. So that would make that an improper integral. And these you're going to have to separate them into two integrals and do one-sided limits. Okay? But the basic premise for all these, once you recognize it as an improper integral, is the same. The way you're going to deal with that improperness is by taking a limit. You're going to replace infinity, or whatever the number is that makes your function undefined, with the limit as you approach that bound or number. And you're going to just choose some arbitrary letter, T, R, whatever makes you happy. Just don't choose whatever your integral variable is. In between the two bounds, again, you're going to have to say for this one from 0 to 1 of this integral, plus from 1 to 2. When you do the limits, you're going to have to do the negative direction for this one and the positive direction for the other one. You will see all of this exhibited in the example videos. Just make sure you check them out. Okay, so you're going to have two infinities plus and minus. In this scenario, again, you're going to have to separate it. You can say 0 is an element of negative infinity to infinity, and then integrate. All right, you're going to have the same integral, so you can go off and do the integral by itself as an indefinite integral, and then plug into your bounds. So basically, once you get to a point that you've solved the integral and dealt with all this scenario business and chosen the right path and then come up with an answer, if you get a finite number, you're going to end up converging. So if you get 2e, 1, ln of 2, whatever the 1/2 the number is, it converges. But if you get infinity or negative infinity, it diverges. All right, don't forget that last part of the improper integral. We're finding the area under the curve. All right, so again, number converges, infinity, negative infinity diverges. Again, all this will be apparent in the example video, so make sure you check them out. Thanks for watching. Have a great day.